right, moving on. So now we're going to move on to ionic compounds with two or more elements. So what these are is these are type 1 and 2 naming rules, but with more than two elements. And so we're going to introduce you to the concept of polyatomic ions. The nice thing is you don't actually have to look at the entire periodic table. You get to go to page 4 of your information book. And on this page, it has listed some of the most common positive ions, so cations, so that aluminum and calcium and barium, so you don't always have to go to your formula sheet. But then it also has a list of negative ions, which includes a bunch of polyatomics, meaning things like carbonate, which includes a carbon and 3 oxygens, or a chlorate, which is a chlorine and 3 oxygens, and it gives you their charge as well. So what we're going to do is we are going to name these polyatomic compounds. To do this, you're going to use your rules for type 1 and 2 for the cation, unless it's ammonium, in which case you're just going to call it ammonium. And then the beauty thing is that the anion, just use the name from page 4. So no changing the end to "ide." So an example of this would be something like sodium with sulfate, iron with nitrate, and potassium with chlorite. So all of these anions are listed on this information book, right? And you just write them as is. And then you just have to be careful. So sodium is a type 1 metal, iron is a type 2 metal, and then potassium, you go back to being a type 1 metal. So the only one that needed the Roman numerals was the iron 3 nitrate. So let's try some. So tin 4 oxalate. Because it's tin 4, we know that it's a type 2. So we're going to put SN4+. And then we're going to go to page 4 of our information booklet and look up oxalate. So we're going to find oxalate. There it is down here. So oxalate is C2O4 with a -2 charge. So C2O4 with a -2 charge. Doesn't look much like a 4, does it? Then we're going to use our crisscross. We're going to bring the 4 down and the 2 down so that you would get SN2 C2O4. Now you need to start using brackets because the subscript applies to the whole compound. You go like that. And then be careful. Whenever you're finishing, you make sure that you put these in lowest terms. So we're going to put that as a 1 and that as a 2. And we are going to say that the chemical formula for this is SnC2O4 sub 2. Awesome. Okay, what about sodium nitrate? So right away I can tell this is going to be a type 1 polyatomic compound. So I've got my sodium. Maybe you're getting used to the fact that sodium is +1. Maybe sodium is one of our popular ones. I bet you it is. Yep, there it is. Sodium is a +1, and then we just have to check out for our polyatomic. So our polyatomic is nitrate. So then we find nitrate, and it's NO3. That's one you're going to use a lot this semester. So it's NO3 with a -1 charge. So crisscross, you're bringing 1s down. We don't write them. And we would say that this is NaNO3. Maybe give the last one a go. This is zinc. The combining capacity on zinc is 2+. Then we look up carbonate. Carbonate is CO3 2-. And then again, you would bring these down, but because they're both 2s, you would simplify to just zinc carbonate. And then we go the other way around. So now we're going to name. So this is calcium with a sulfate. If you don't know that, you can go to your information booklet. SO4 is sulfate. Because we are mixing with calcium, maybe you're getting used to it, but you could also look up here. Calcium is only listed once. It only has 1 combining capacity. And so I'm going to name this as a type 1. I'm going to say that this is calcium. And something I haven't mentioned kind of out loud, but is that you never capitalize elements. So the formula, like the chemical name is capitalized, but the actual naming, that is supposed to be a little c. It kind of looks a little bit big, but just know that anytime we write these, they're supposed to be small. So this is calcium and then sulfate, because in this course we're going to use pH, right? Yep. It always varies. Okay, this one, it's starting with the polyatomic compound, so this is definitely going to just be kind of like a type 1 in a way, and you're just going to put ammonium, and then you're going to end this one. So this one, because it starts with the polyatomic we're just going to write as ammonium. Not that you can read that. Let me see if I can write that a bit nicer. Ammonium. A-M-M-O-N-I-U-M. And then because it's ending in oxygen and not a polyatomic, you go back to the ending of "ide." So this would be ammonium oxide. Okay, and then last one, Cr. Is Cr chromium? Yeah, chromium. When I look at chromium right here, I can see that chromium has more than one combining capacity. It can be chromium 2 or chromium 3. So let's look what it's with. So this is chromium. It's with a phosphate. So if I look at phosphate down here, it's a 3-. And since there are no subscripts, it means they must have canceled out. So it must be chromium 3+. So I'm going to write chromium phosphate. Whoops, sorry, I forgot the Roman numeral. Chromium 3 phosphate. Now, I don't know if you noticed when we were looking at the polyatomic sheet, when you have these type 2, you know, everybody's too lazy in the world. And so writing chromium 2 or writing chromium 3 or writing copper 1 or writing copper 2 is sometimes too much work. So they do give them alternate names. And so you could call this chromic instead of chromium 3. So just throwing it out there, if you ever do see it, chromic phosphate is an alternate way of naming a type 2 compound instead of using the Roman numerals. But personally, I can never remember which one's which, and so I just like writing the Roman numeral. But you may see this throughout the course, that instead of chromium 3, they write chromic. I did choose the right one, right? Yeah, cool. Awesome. Okay, go and practice these type 1 and 2 polyatomic